All right, so remember tomorrow we're going to start reviewing for translations and reflections quiz. And remember on Friday that you actually have a quiz. Today we're going to finish up talking about reflections. And the first thing I want to comment on is a little bit of a review from yesterday. When we're dealing with reflections, if the negative sign is actually inside of the function, remember it actually ends up being reflected over the y-axis. So that represents a change that's a horizontal change we talked about yesterday. And then if it's on the outside of the function, remember how it's going to be reflected over the x-axis. Okay. So those are the two reflections that we've talked about. It can be reflected over both. And if it was reflected over both the x and the y, you would end up with a graph that looks similar to this. Okay, so it can be reflected over both for those two. The thing I can't remind you enough of, though, is that reflections are always done first and then the translations. So make sure tonight when you're doing your homework that you always do the reflections first. So if we were to describe what's happening with these, the first thing I'm going to say is that yes, A was reflected, and since it's inside of the function, I know that was reflected over the y-axis. So that's why how I'm going to describe this transformation. I also know that this -1 tells me that was translated right 1. Over here, the 2 tells me that it's translated up or down, obviously. But what I need to pay attention to is this negative right out in front here. That tells me a reflection. So it's actually reflected, I'm going to abbreviate so I have some more room here, over the x-axis. So it's going to be vertical change. It is moved up 2, so it's translated up 2. And it's also translated right 1. Okay, so we have that also. The last one here, we're talking about the square root function still. And the only thing that happened with this one is that it was translated up 2. Remember, it doesn't matter if the 2 comes out front or if it were to come behind. As long as it's outside the function, it still means that it's translated up or down if it's outside. Perfect. The next part I wanted to show you is when we're actually dealing with a graph, okay? Now I'm thinking about this very first one. I see that it's a reflected, okay? So what I'm going to do first of all is I'm going to graph in red what the original graph looks like, just like this, okay? Now once I reflect it, I'm going to do that part in blue. The reflected part is on the outside of the function. If it's on the outside, it's going to represent some sort of vertical change. So this is what the new graph is going to look like. Okay, so the new graph is in blue. Okay. And then I have to actually translate it. So from that blue graph, I need to go 1 to the right, so 1 right, and up 4. Okay, so I'm going to move my vertex, which is this point right here. I'm going to move that 1 to the right and up 4. So here's my new vertex. It's still a V that's facing downward. So the green graph is my latest graph, okay? Sometimes it helps to graph all the pieces so you know where it's going to end up, okay? So that's the first one. Let's take a look at the x squared graph. So we know it's going to be a parabola. So I know my original shape. Again, I'll do that in red. This is the original shape of my graph. So it looks like that. The first translation I have to do is the reflection. Now I know it's inside the function. Inside the function means it's going to be reflected over the y-axis. What I notice when I reflect it over the y-axis is that I get the same graph because it's symmetrical. I get the same exact graph that I had. Okay, so I took care of that reflection even though it's the same graph. And then the last piece I'm going to do, and my final graph will be in green, is going to be moving that graph down too. So I'm going to take each of the points and move it down too, so I get a new shape to my graph. So my final graph is in green. Okay. Remember, reflections will always come first. Now sometimes they're going to ask you to actually just write the equation for the whatever is going on, the reflection and translation. So I know I'm dealing with the absolute value function, so I'm going to kind of start that. I know it's going to look like this. And it's reflected over the x-axis. So that tells me if it's reflected over the x, now remember, this is the y and this is the x. If I have something reflected over the x, that means that it's a vertical change. So it's going to be outside the function. So I know it's outside of here. Okay. It's translated up 7, so I know that occurs back here. And it's left 2. So it's inside the function, it has to be counterintuitive. So I'm really going to write x plus 2. And that's all I need for that one. If I go on to the next one, now I'm dealing with x squared, okay? Different than the absolute value that we dealt with before. It's reflected over the y-axis. So if I think about that, if this was my original graph, it's going to be reflected this way, okay? So now when I'm down here, I know it was a horizontal change that just happened. So I'm going to start writing this out. And I know that the negative has to be on the inside of the function. So the negative is going to be applied to the x on the inside. Okay. It was reflected over the y-axis, got that part, and it was translated down 6 units. So I have to close this off. It didn't have any left or right movement, and it went down 6, just like that. Okay. Last problem on here. We're talking about the square root function. It's reflected over both x and y axis. So that part's easy. I know a negative goes on the outside and a negative goes on the inside. And translated right 1. Now the most important thing of why I wanted to put this problem in here is if I just write it like this, translated right 1 would mean it would be minus 1. If I go ahead and carry that square root all the way over, there's something wrong with this, okay? Notice how this negative right here is only being applied to the x right now. Very important. You're going to need parentheses around this, okay? So that reflection applies to that whole translation of moving 1 to the right, okay? Don't forget parentheses if you have a negative on the inside. The last part is I need to move it down 9, so that's going to be on the outside of the square root right there. Okay. I'm also going to ask you to look at a graph. And we know this represents the square root of x, so that's the function we're dealing with here. And we're going to have to write the equations for it. I'm going to start with the blue one because this graph hasn't been reflected at all. So it's just been translated, maybe the easiest graph on here. I noticed that it went 2 to the right and up 5. So I'm going to think about going 2 to the right, counterintuitive. So I'm going to go minus 2. And then I went up 5 from there, so I need to make sure that's on the outside. Okay, so that one's pretty easy. The next one I'm going to do is this black graph. And I can see that this one was reflected over the y-axis, which tells me there's a horizontal change. I know horizontal changes like left and right motion, so guess what? I'm going to actually know that I know that it goes inside the function. Maybe I'll need a set of parentheses underneath here, I think. So then from there I went back 2. That really means x plus 2. Like I said before, that negative's only applied to the x. I need to make sure I put parentheses around it so it's applied to everything underneath there. Last part is I went down 2, so I'm going to subtract 2 on the outside there. Alright, let's move on to the red graph. On the red graph, what happened is it was reflected, it looks like, over the x-axis. So our negative is going to be on the outside of the function. It was moved right 3, which means a minus 3 or a counterintuitive underneath there, and it was down 1. So it goes right there. The last graph, and the reason I saved it for last, is you can see that it's been reflected twice. It's been reflected over the x and over the y-axis. So I'm going to put a negative on the outside and a negative on the inside. Okay. From there, it was moved backwards 1, left 1. So that means it's going to be x plus 1. Negative has to apply to the whole entire thing, though. From there, it was also moved up 2, 4, 6, 8. So I'm going to have a plus 8 on the outside. Last thing that I want to go over, oh, actually, sorry, there's a couple more. Um, the different transformations. So sometimes it's going to ask you, can you actually describe them and what's happening from the original graph. So the original graph here is the absolute value of x. So in this one, it's just translations. So this graph was translated left 4 and down 1. This graph over here was reflected. Think for a minute what you think it was reflected over. It's inside the function. Horizontal change is going to be reflected over the y-axis. Okay. This one down here was reflected as well. It's the opposite of the last one. So this one's going to be reflected over the x-axis. And then the very last one that we have down here, this one's reflected over the x and the y. So over x-axis and y-axis. And this one was also translated. Oh, did I miss a translation on the last one? I did. We'll have to come back to that. Sorry about that. This one's translated left 4 and down 5. I notice here, do you see how the negative is applied to this whole thing inside the parentheses? So they're kind of following that rule right there too. I forgot a translation on this one. I apologize about that. It was translated up 5 as well as being reflected. Okay. Now this piece, if I have a reflection on the outside of the function, and so it's telling me this one's reflected over the x-axis, and it's moved left 3. So what I have to try and do is take and apply those transformations to this function. So I know f of x is going to equal the absolute value of x, but it was moved left 3, so I'm going to put that in there. And I know it was reflected over the x-axis, and that's on the outside, so it'll look like this. The next one asks me to move it down 5, reflect it over the x-axis, and reflect it over the y-axis. And I have to apply that to the square root function. So I'm going to say f of x reflected over the x-axis. Also over the y-axis, so on the inside. And it was moved down 5. I could also have the 5 out in front there. That would have worked fine. That would have worked fine too. And then the last one on here, I'm dealing with the x squared function. And looks like I have a reflection. I have a translation up 3 and have a translation right 1. So what I'm going to do is I'm going to rewrite it. I'm going to put the 3 in the front this time. So I have 3 plus, that's the up 3. I have a negative on the inside, so I'm going to have to put that inside the parentheses. So it's going to have to be applied there. If I just write x minus 1, I'm forgetting one item. That negative still needs to be applied, so I almost need a double set of parentheses there so that negative's applied to the whole x minus 1. Okay. Now sometimes they're going to give you a graph that we're not familiar with, so it's not the square root function, it's not squared or anything like that, and we're going to have to reflect it. So I'm going to do the first reflection, this red one here. I can see that it's been reflected, and it's on the inside of the function, so it's going to be reflected over the y-axis. So I'm going to start by doing that one. So I know this point is going to end up on the opposite side over here. Okay, so I can kind of tell this point is be the point of the v. Okay, so this is what the first part of my graph looks like. Now I know this point is going to end up on the same spot on the other side, so it kind of looks like this, and then this part extends out. So that's what it'll look like reflected over the y. Students tend to struggle if the graph is over the middle part here and over the y-axis. They can't visualize how it's flipped. Think about folding the piece of paper in half and what it would look like after that. The next one has it reflected over the x-axis. So I'll do that graph in blue. So I'm going back to the original black graph and I'm thinking, how would that look if I reflected over the x? So this point right here is going to be reflected down here. This point right here stays there because it's actually on the x-axis. this point ends up 2 down instead of being 2 up. And same with this point. So I can kind of draw in my graph from here. Last one, the green one, it's been reflected twice. Now, I can reflect, it doesn't matter what order you do the reflections in, as long as you get them all in. So what I'm going to do is I already reflected this blue graph over the y-axis. I'm going to take and reflect it over the, I'm sorry, I already reflected over the x-axis. I'm going to take and reflect it over the y-axis. So now this point on the blue graph, to make my green graph, is going to go all the way on the other side. This point right here ends up being right over here. So I'm reflecting everything over the y. This point right here ends up over here. This point right here ends up over here. So then I just have to, oops, something, oh wait, no, that's right. So it looks something like this. Okay, so that's what my graph will look like. Kind of confusing when there's a lot of reflections on there, but I think you guys can get the main idea. Okay. All right, so the last piece, what happens to the graph of y equals f of x in the following situations? What happens to the graph when I replace x with an x minus 7? Well, if I have y equals f of x, and I replace it with my x with x minus 7, what happens? Well, I can tell right away that it's going to be translated. It's inside the function, so it's the opposite of or counterintuitive. So it's going to be translated right 7. If I replace the y, so this is the second one here, replace the y with y plus 2. So instead of having y equals f of x, now I have y plus 2 equals f of x. Well, guess what? It's hard to solve that because I don't have y equals. So I need to move the 2 to the other side. Okay, so I end up with something that says y equals f of x minus 2. It's on the outside of the function. So this one's actually going to be translated down 2. Last one here. If I replace x with negative x, so I have y equals f of x as the original equation, I'm going to replace it, x with a negative x. It's inside the function. I know it's going to be a reflection, so it's reflected over, inside the function is going to be a horizontal change, so it's going to be reflected, I got to think about this for a second. Here's the original graph, reflected that way. It's going to be over the y-axis. So that should help you with all of the problems that you have on your homework. You want to check all of those out. I will also post these same notes, the ones that I have filled out in case you have questions or I went over something too fast. The notes will be posted. It'll say math notes like we do normally do on Schoology for 9/28. Okay, I'll have the math notes posted with all of my items on it for you. Thank you so much. Good luck on your homework. I want you to finish all of Transformations Worksheet B. Okay, remember you can check the answer key on Schoology. It's already posted. Thanks so much.